Okay, so it looks like we have about 60 people watching this live stream. So, as I said in my email, those of you who want to ask questions, just jump into the Zoom meeting room, which is also active right now, and just ask your question. Just unmute yourself and ask a question, and then I'll try and answer that question in the live stream on YouTube. So I'm not expecting any interactivity, although that would be nice. But let's go ahead and solve some problems, and I hope that that process is going to be useful for you people. Now, obviously, several of us will not have access to Pruter at this point. And so I'm going to be working assuming that you don't have access to Pruter. You can see that I'm doing this in Visual Studio Code. I'm not doing this in Pruter. If you want help in getting set up on Visual Studio Code or any other editor on your system, whether it's Windows or Linux or Mac, then either look up on the web, and if that doesn't work, you ask your friends. If that doesn't work, you email me. I'll give you directions that are specific to your platform. Broadly speaking, there's three primary categories. If you're on Linux, then you just need to install the GCC compiler. Most cases it comes installed already. On Mac, you just need to install Xcode from the App Store, and on Windows you need to install Ming I can't remember, MingW, the base installation of this. And once you've done this, you will have access to GCC. And once you have access to GCC, then everything is going to work just fine. Then whatever editor you do, you use, you can use Notepad even, it's going to work just fine. So let's begin assuming that you have access to GCC or Clang or one of these other compilers. If you want to use one of the online compilers, that's fine too. If you don't have internet access all the time, it might be better if you install the GCC compiler so that you have access to it on your local machine. But otherwise, the online compilers will work just fine also. So I wrote a small practice problem here. It's just adding up a couple of numbers, and the way to compile it is to write GCC, the name of your program, in this case easy.c, then with the -o flag, and you just specify what the name of the executable is going to be. If you are on Windows, then the executable is going to take a suffix .exe automatically. If you are on Linux or Mac, it won't. So if you're on Windows, then if you want to run it, you will say test.exe. In this case, it's expecting 2 inputs. So I put in 2 inputs, and it added the 2 numbers as we expected. If you were on Linux or Windows or Mac, and you had said gcc easy.c -o test, it would have given you an executable called test, and you would run it using /test. That's the one difference. And if any of this is not clear, you email me. I'll fix it for you, or I'll help you do it. But I'm assuming at this point that everybody has the ability to compile and run C code. If that's not true, then you let me know and I'll help you fix it. Okay, so with that said, let's work through the first problem that we were going to do today. So some problems I will do with based on the practice problems that I've already given. Some problems I will do that I didn't give as practice problems. I will give them now, and I will expect that people will solve them in real time while I do these problems that I gave already. So let's start with this one, and then I'll give another one, and then if time permits we'll do a third one. So here what we are saying is we are going to find the GCD, the HCF, and the point here is that we want to use a function to do it, but the function has to be of type void. This is sort of a constraint, a bit of an arbitrary constraint. So let's say that we did not have this constraint. If we did not have this constraint, how could we solve this problem? Okay, so we would take two numbers as inputs. Conveniently, that is already set up here for us. Let me just make this a little bit more attractive. So this is my main function. I'm taking two numbers as inputs. And I'm calling the GCD function. Now the GCD function is going to return an integer, and that's the integer that I'm going to print out here. So this is pretty straightforward so far. Now what would we do in this situation? How would we define the GCD function itself? So I'm sure you've tried to do it your way. I'm going to use the Euclid algorithm, which is so much simpler. So the Euclid algorithm essentially says if the two numbers are equal, then you return any one of them. And if A is greater than B, what do you return? You return the GCD, the greatest common denominator of this. And in the third instance, if A is less, actually I don't have to write that at all. In the third case, if A is less than B, we return the GCD of A comma B minus A. So the Euclid algorithm essentially says that the greatest common denominator of any two numbers, let's say 57 and no, let's not say 38, let's say 171, GCD of 157 and 171 will be the same as the GCD of 171 minus 57 and 57 without calculating this at all. Now we know that this difference is 114, so the GCD of 114 and 57 will be the same as the GCD of 114 minus 57 and 57. And what is that? That is 57. GCD of 57 and 57 will be 57. We return any of them. So what this means is that the GCD of 57 and 171 is also 57, which is true. So this GCD is a very nice, the Allocation algorithm is a very nice simplification of, it's a very simple way of calculating the HCF, and that's why it's always used by people. A couple of exceptions. Let's not handle the exceptions here. So this is it. This is my GCD algorithm. This is using recursion. We can also write a version that doesn't use recursion, that uses iteration. I will do that next, but right now I'm doing this using recursion. And what's going to happen is, well, we'll see what happens. So I saved it and I compile it, and then I say exe, and let's use the same example, 171, and you can see that the HCF is 57. It works. Hopefully everybody can see the screen. The numbers ideally should be bigger. Let me see if I can make it slightly bigger. Oops. I'm trying to get the font to be bigger. Just give me 1 second. Yeah, that's not really going to work very well. Okay, I'll see if I can fix it by the next time we have this. Hopefully you can see this at least a little bit clearly. Let me make this more distinct at least. So we do GCC and we do test and we enter the numbers 57. Let's see if it's 57. Okay, so this is how I would do it if I was doing this while I'm allowed to use an int GCD function. But now the rules are changed. The rules say the function has to be of type void. Okay, so what has to change? Now clearly, if the function is void, now I can't get any return from the function, but it has to calculate the GCD anyway. So obviously I have to write the result somewhere here. So let's say that I do this like this. So now I'm going to use iteration. I'm going to say while b is not equal to 0, int temp equals a modulus b, a equals b and b equals 10. And then I will say printf a. And now I don't need this line anymore. And of course I don't need to return, but I'll just return anyway. Now, what is going to happen? Let me compile it and let me run it and let me enter the same numbers again. Actually I have to say A. Oh, it never happened. Why did it not happen? Because when I'm setting this, let's say I am running this multiple times. Oh, I never called the function. Let's see. So I have to say GCD A comma B. Sorry. So now let me clear the screen. This is the 171.57. So what is happening? I'm passing in two numbers as inputs, 171 and 57, and now I'm setting int temp equals the remainder when I divide 171 by 57. So actually let me debug this so you can see what's happening in real time. So the very first time I get a remainder of 0. Why is that happening? Let's see. Okay. This is fine. And why is it giving me 0? Okay, so let me do the following. Let me fix this, and then we'll talk about why this one doesn't work. So what I'm going to do now is I will skip straight to the solution of the version that I have up here. So what I'm doing is I am taking each of these variables and I'm saying now I'm going to use pointers instead of the actual R values, and I'm going to call the function using the address of A and the address of B. So in each situation where I was previously working with the actual values stored in the variables, now I'm going to work with the locations. So let's see, what do I do? And I will say printf CF is A. I think this is going to work, and because I already solved it. Okay, hopefully there's no bug in this. Good. So at least this one works. So what has happened? Somebody has a comment? No. Okay. So let's quickly look at this code. What is this doing different from what we were doing before? And the result is the same, but something is slightly different. Instead of passing the value of A, we are passing the address of A, and likewise for B. And then we are working with the dereferencing operator. So once we have sent the addresses in, then everything else we do the same way that we would do it with the values. All we have to do is dereference each of the pointers that have been passed, and then yield the output. So this is how we solve the problem given this constraint. The constraint that we have a void function, a void return type for the function, and the function is passing in pointers. I tried to work this out with just the premise that you have a void function, a void return type, and we have values being passed, but it looks like my logic is broken and so I'm not going to spend more time in this live stream to debug it. I'm giving that as homework. Somebody should do it and show me. Obviously, it can be done. It's pretty straightforward. But this is the solution to the problem that I gave you in the practice set. You do the GCD calculation using a void return type for the function and by passing int pointers instead of integers as parameters. So this is how we solve this problem. Let's take a look at a different problem. Let me open up another problem. Okay. Yeah. Let's take a look at this one. So here, what we have is we have a couple of matrices. The matrices are going to be of arbitrary size, and you have to add them. So it is guaranteed that the matrices are the same size, otherwise you have to do some exception handling. But given that, we are asking you to solve this problem without using arrays. Now, if you've been following the slides, then, and in fact we talked about this in the class before everything went crazy, the one thing that I would like everybody to take away, if you take away nothing else from the second half of the course, is that all arrays are ultimately just pointer operations. All structures that we will talk about in a couple of weeks are also just pointer operations. It's all just pointer operations implemented in certain ways. So we are saying, let's just add two matrices with dynamically assigned sizes. Let's add them without any static array use. So for this, we can do this a couple of different ways. I'm going to show you one way to do it. So what am I going to do? Let's save this and let's make a new file here, medium1.c. Okay, so let's put in the boilerplate include .h int main. Now what am I doing? First of all, I need the integers m and n to specify the matrix dimensions, and then what else do I need? I need to specify, or I need to allocate memory space sufficient for three matrices, two matrices that are the input matrices and one matrix that's going to be the output matrix, and I am going to use dynamic memory allocation. So what will we do? We'll define these matrices using pointers, and because we have integer values for the matrices, I'll use int pointers. So I'm calling these pointers m1, m2 and sum, and now we are ready to take some inputs. Let me format this better. Int pointers to store matrices. Now we'll take some inputs. First we'll scan the two inputs. Let me make this more user friendly. Printf, please enter the matrix sizes. Make this more readable. Alright. And now we have to do some memory allocation. How do we do the memory allocation? Let's say, hopefully you guys now know the syntax for malloc. We're going to use malloc, right? We're doing dynamic memory allocation. What are we allocating? We are allocating sufficient space to store m times n integers. So what do? We say malloc m times n times size of int. That's what we do. What's missing? We have to typecast this, right? Malloc doesn't know what the pointer size, what is the nature of the pointer to which it is allocating this much memory. So we have to say int star malloc, and now this will work. We are typecasting to, oh sorry, it shouldn't be a, it should be m1. So now malloc is being used correctly. We are saying store n m times n integers in starting with the address m1, or the address being pointed to by m1. And similarly we need to do this for m2, and we need to do this for sum. Okay, now we need to get the matrices, we need to get the input matrices. So how do we get the input matrices? We could do this in line, but let's make a function to do it. What will this function take as inputs? It's going to take obviously the size, and what else will it take as input? It's going to take the address, where to store. It needs all three of these things in order to store correctly. And you would just pass the m1, but then if you don't know the shape, whether it's n cross m or m cross n, and you'd be in trouble. So we need to get both these inputs. So let's quickly define this function before we go any further. What will the function do? It has to scan matrix inputs. Okay, so how do we scan these inputs? Let's say, what should the return type be? We don't really need a return from this because we are sending in the first address at which the matrix elements start being stored. We are passing that in, and that is not going to change. So we need a void matrix really. And what are the parameters? We have m, n, and what is the type of this last one? It's a pointer, an int pointer pointing to the matrix address, the first element of the matrix. And now this is more or less straightforward. If you guys remember how you handled two-dimensional arrays, the scanf works more or less the same way. You can't avoid the nested loop. I is less than m, I plus plus. And notice how Visual Studio Code is handling the indentation for me automatically. It's also helping me by debugging my code in real time, in the sense it's pointing to errors as I make them. And so in all ways it's an excellent editor. So now we'll scan one element at a time, and the elements will be separated by spaces when I'm doing the individual rows, and they'll be separated by lines when I'm doing the individual, when I'm going to go to the next column. Now what has to go here? This is sort of the most important part of the whole code. Everything else is sort of clear-cut, straightforward, intuitive. What are we going to put in here? So we are going to scan, and we're going to scan to an address. That address has been passed here. Yes, but we also have to handle the I and the j. So what we are saying is that the size of the matrix is m cross n. What that means is that when the value of I is I, then we are working on the ith row, and the jth column. So this is what I'm doing. I am scanning to this memory location. I start with the first element, the location of the first element, and then I jump n times I locations ahead, and then j more locations, j more integer boxes ahead, and then in that box I store the I comma jth element, and then I scan a new line. At that point I am now taking inputs for the next row. This is my read matrix code. And how do I print a matrix? I essentially do the same thing as this. So we want to debug this code, so we want to make sure that whatever inputs we are taking are printed out correctly. What are the parameters for print matrix? The same. The m, the n, the matrix pointer, and the only thing that changes is that instead of a scanf, we'll have a printf here. We'll have a printf here, and that's it. No, one more thing. Remember that for printf, we don't use addresses, we use values. So we dereference, and now it's done. We have a print matrix command available also. Let's debug this. We've spent a lot of time getting this code together. Let's debug it. So for now, I will just use matrix M1, and I will take inputs M and N, and then I will read matrix M1, and I will printf the matrix you entered is and then I will print matrix m comma n comma not m1, the address, and finally return 0. Okay, so if I have done this correctly, then I should be able to compile medium 1, let's see. Oh, I forgot to use stdlib, which I have to if I'm doing malloc. Include stdlib. Okay. Okay, now the moment of truth. Let's say 4, 3. So I have 4 rows and 3 columns. Let me put in the entries. 2, 3, 4, 1, 1, 2, 3, 6, 2, 3, 4, 1. That should be enough. Why didn't it break immediately? Well, it broke, and that's what matters. So you can see that my code is working so far. The 4x3 matrix that I entered has been printed out. Okay, so that means that so far we are doing okay. Now, what do I need to do differently? I have to read the second matrix in. So notice that I am programming in a modular fashion. I am defining the functions when I need them. I don't start by trying to figure out all the functions I will need and define the functions and then go write the main function. I am writing my main function. When I need something in the main function, I write a function. So that's always a good way to go. Let me make sure. Okay, let me make sure that I am not putting in anything I don't need. Let me remove this. So now I'm reading these 2 matrices. Now I need one more function which is going to add the 2 matrices. I have to add them. So what will be this function? Obviously it's going to be a well, not obviously, but it can be a void function again, because I have specified the sum pointer, so I know where the result is going to be stored. I don't need that to be sent to me. So what will this take as inputs? It has to take the address of matrix 1, the address of matrix 2, and the address of sum. It has to take all 3 as inputs, and then I will be able to print this. Let me not bother with this. Okay, so what will this matrix look like? The sum matrix or the add matrix? Did I say add or did I say sum? I said add matrix. Okay, so what will this look like now? It's a void function, and it's taking 2 integers and 3 pointers. Let's call them A, B, and some here. And now, what will this do? Actually, we can borrow most of the code from here. Oops. So I have this, and what do I need? I in fact don't really need these, because I need just one line of code. What is that one line of code? So for the ijth element, the value stored here should be equal to the value stored here plus the value stored here. That's all. That's all I need. My sum is ready. So this is it. This is my code. It's ready. Now what do? I test it. Okay, so let's see, will it work? I'm going to work with a small matrix now. I don't want to enter too many numbers, so I'll say 2 and 2. And now the first matrix is 1 0 0 1. One, 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 one. Huh? Why is it not? Oh, it's taking, for some reason it's taking one extra input before terminating. That's a bug in my logic, which I should debug, but let's just run it again to make sure that this works. Let's see. So matrix size is 2, comma 2, so it's a 2 by 2 matrix, and I'm saying what? Let's say 1 1 1 1, 2 2 2 2. You can see that it spits out 3 3 3 3, which is exactly what is needed. Actually, let me stop this. Show this one more time. I don't know why it's taking that one extra line as input. This is fine. This is fine. Again, I am not going to try to debug it in real time. Let's just make sure it works one more time. 2 comma 2. First matrix is 1 1 0 1. Second matrix is 2 1 0 2. You can see the output is 3203. 3203 is the correct sum. Let me make this slightly more readable. Yeah, now it should be fine. GCC medium 1.c minus O test CLS. Alright, one last time. 1 0 2 0 1 1 2 1. So here you can see the output 2, 1, 4, 1. 2 is fine, 1 is fine, 4 and 1 are all fine. We know how to add these matrices. We can also subtract these matrices, multiply these matrices. I think on one of the slides I have this problem for you. Multiply two matrices. Let me give that as homework also. I've shown you how to add them without using arrays. Why don't you try and multiply them without using arrays? It's straightforward. This is the only function you change. The only thing we are doing different now from the two-dimensional arrays is we are using directly the pointer address. The two-dimensional array is just a different way of handling the same memory. And here we are using malloc, and we are using this addressing scheme to store the memory, to store the array in memory. This works the exact same way, except that the memory allocation is more flexible. So we've covered a couple of problems, and I don't think we have time to get into the next one. So why don't I give this as homework again? And I am also curious to understand if what we've done today has been useful. I know that there's been about 80 people watching, and I'm interested. Yeah, I can't see the chat. I can't code and talk and see the chat simultaneously, man. You have to ask doubts on Zoom. Nobody asked any doubts, but that's okay. If anybody has any doubts about what we've talked about today, now is your time to ask. Nobody wants to be the first person to ask. Can't see the chat while I'm coding in the other screen. Ask doubts on Zoom. Somebody said we should free the memory, which is so it's not really necessary, because when the program terminates, the memory is freed automatically. But if you want, you can say free M1, free M2, and free sum. I mean, that's what it would be syntactically. Absolutely unnecessary to do this. The only time when you want to free is when you expect your memory resources to be a limitation, in the sense that you have to make exponentially large arrays or exponentially many arrays. Let's say you're doing some dynamic programming. We'll do some dynamic programming. In those situations, fleeing becomes very important. Here we had 3 arrays, 2 by 2 is really not that relevant. Somebody says, please send the code. Please send the code. What I'll do is, I will share this code on the website. That I think is the right thing to do. So we've made this, and I'll share both these on the course website as solutions to the practice problems. That works, right? All right, so let's not keep this open much further. Let's stop for today, and let's do this again on Friday. I will send out a link to a Google form asking you guys for feedback about how you think this is going, how we can improve this, if it has any value. So I'm curious to get feedback from you, because right now this is just me talking into the computer, and I have no understanding of whether this is of any value to you. So hopefully Friday more people will ask questions on Zoom, and by Friday hopefully you guys will give me a sense for whether this is useful for you. So let's stop for today. I'm going to stop the Zoom meeting, I'm going to stop the YouTube stream, and then Friday same time, 12 o'clock, I will see everybody, and then we'll solve some more pointer problems.